Welcome in the subject Mechanical System Design. This subject is included in B Mechanical 2015 pattern. I am Professor E.P. Godke, Assistant Professor in Department of Mechanical Engineering of Resendi College of Engineering and Research Center, Yeola. Today, we'll see the unit of our subject Mechanical System Design, Statistical Consideration in Design. So what are the statistical consideration in design that we are going to study in this chapter? So before going to start actual implementation of statistical consideration in design, we must know the basic points or parameters related with the statistical data. So first point is the causes of variation. So what are the reasons due to which there is a variation in the observation or data collection is seen? So that is called as the causes of variations. So there are basically three causes of variation. One is variation in material, second variation in the manufacturing process, and second variation in workmanship. So because of these three causes of variation, there will be a variation in the observed data. So first, variation in material. It means whenever there is a change in the material or material properties, there will be change in the observation. So that is called as a variation in the material. Second one, we have a variation in manufacturing processes. So if manufacturing processes are going to change, or if there is any kind of fault in manufacturing process, or if we select the wrong manufacturing process for manufacturing of any particular component, then there will be a variation in the observation data. Then second one is a third one is a variation in workmanship. Means it is called as a human error, or due to change of operator, there will be a variation in the data. So that will be a variation in workmanship. So these are the three main causes of variation. First, we must know what is meant by statistics. Statistics is nothing but drawing conclusion from observed data. Statistics is nothing but it is the study of observation and collection of the data, and whenever we are drawing some conclusions from that observed data, such a method of drawing conclusions is called as a statistics. So for example, a shaft manufactured in a batch, for that we are getting number of observations. For example, type of material, then number of input parameters and diameter. That will be the measurement or observed data. And based on that observed data, in one batch, we can draw the some conclusions or charts. That will be called as a statistical methods. Next point is the types of causes of variation. Means in these three types of variation in material, variation in manufacturing process, and variation in workmanship. These are the causes of variation, and these are also called as the types of causes of variation. So variation in material, variation in manufacturing process, and variation in the workmanship. Due to this variation causes, so there will be types of causes. So first is assignable cause, and second one is a chance cause. That is also called as a non-assignable cause. Assignable cause is nothing but they do not occur at random, but are the result of change in material, manufacturing process, and workmanship. Means assignable causes, they do not occur randomly. That causes are assignable. Means we know that causes or that variation is occurred, or cause of variation is occurred, that is called as a assignable cause. Okay, they are due to what? Result of change in material, manufacturing process and workmanship. Means if we change the material, if we change the manufacturing process, and if we change the workmanship, there will be a assignable causes occurs, which is a one type of a cause of variations. Second one is a chance cause or non-assignable cause. It is also called as a non-assignable cause, which occurs at random. Means anytime that cause or error can occur. So that will be due to the complex and parameters which can be either traced or not measured. Means what? Sudden variation or sudden error is called as a assignable or non-assignable or chance causes. Means that causes can occur at random due to complex and parameters which can neither trace nor measure. Means that errors that we cannot predict. So suddenly or randomly that error occur due to that variation in the observation can be occur. Next point is a terminology in statistical analysis. Means if you want to do the statistical analysis, so what are the different terms that we are going to study, that we will see here. So first one is a population, second one is a sample, and third one is a random variables. Okay, so what do you mean by population? Population is nothing but a entire amount of a number of component is called as a population. Okay, for example, the Indian population is a 100 crore, so that will be considered as a population. Okay, then sample if from population number of components are selected for a test, then it is called as a sample. So for example, out of 100 crore population, we select 1000 samples for uh, analysis. Okay, third one is a random variable. So out of that 100 samples, we are making the variables, for example, X, Y, Z. So in that sample size, we can categorize the parameters or properties that are called as the variables, random variables. Okay. Next point is a frequency distribution. In that, three parameters are there. One is a class interval, second one is a class frequency, and third one is a class width. So here one example is given, class interval of tensile strength 620 to 640. Then class midpoint is a 630, that is a class width, and class frequency is what? 5. So for this class interval, midpoint is a 630 and 5 is a frequency. हमारा लेक्चर पॉज करावा लागेल. लेक्चर पॉज करावं लागलं ना. हा मी आता रोज एक डोंगर लावलेलं आहे ना. रोज एक एक दोन लेक्चर करणार आहे मी. हा पीपीटी वरून लेक्चर कन्वर्ट करायचं. एमएसडी प्रत्येक युनिट वर एक एक लेक्चर करतोय मी. हा 6 युनिटचे 6 लेक्चर बस. चालूच ठेवा ना. Next is a method of presenting frequency distribution. So frequency can be distributed in two ways. So first one is a frequency distribution by histogram, and second one is a frequency distribution by frequency polygon. So here we can see that two graphs are there or two charts are there. One is called as a histogram and second one is called as a frequency polygon. So here, if it is present in the column form, then such representation of frequency is called as a histogram. And if it is present in the form of points or straight line, then it will be called as a frequency polygon. So for same observation, we can represent the frequency or we can distribute the frequency by histogram as well as by frequency polygon. So what are the parameters for frequency distribution? So there are 3 parameters that are going to consider for frequency distribution. One is a central value, second one is a dispersion, and third one is a variation, or it is also called as a spread. So these are the 3 important parameters that are considered for frequency distribution. Next, measurement of central tendency. So how central value or central tendencies can be measured, which is required for frequency distribution or statistical analysis. So measurement of central tendency. So first point is the arithmetic mean. Okay. So arithmetic mean is nothing but sum of observation divided by total number of observation. Means In a batch, total number of observations are there. For example, if a sample has a n observations like x1, x2, x3 up to xn, then mean will be the sum of that n number of observation divided by number of observation. That is called as a mean, arithmetic mean. If the sample has a n observations like x1, x2, x3 up to xn, then arithmetic mean will be the ratio of sum of observations divided by total number of observations. So here x1, x2, x3 are the different observations in a sample. For example, we take the 10 shafts with the diameter after manufacturing. So one may have a 10.01, one may have a 9.99 diameter, one may have a 9.55 diameter. So that values or that answers are called as observations. Okay, that are the value of x1, x2, x3 up to xn. Divided by n is the total number of observation in the sample. So how many observations we are? If we calculate x1 to x9 or x10, then total number of observations will be 10. So sum of observations divided by total number of observation is called as a mean or arithmetic mean, which is represented by mu. Now, if observations x1, x2 up to xn or xk are occurs with the frequency f1, f2, fk, then the arithmetic mean will be the f1 x1 plus f2 x2 plus f3 x3 up to fk xk divided by frequency total f1 to fn or fk. So this is also a formula for arithmetic mean with frequency, and this is the formula for arithmetic mean without frequency. Number of observations divided by sum of observations divided by number of total number of observation. Here again same, the sum of observations along with frequency divided by total frequency, that is also called as a arithmetic mean. So that is the first parameter that we are going to calculate in calculation of the central tendency for frequency distribution or statistical analysis. Second one is a median. Median is nothing but it is a middle value of observations arranged in increasing or decreasing order. Means if the number of observations are arranged in increasing order, or we can order arrange in a decreasing order, then the central or middle value is called as a median. Means for example, if you have a number of observations like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 10, if we arrange that observations in increasing order, then 5 will be considered as a medium value, or decreasing order from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is decreasing order. Again, in that decreasing order, if we consider the middle value, that middle value is called as a median for that observations. This is the second parameter that we are going to calculate for measurement of central tendency. Third one is a mode. It is the observation that occurs most frequently. Means if we have a number of observations 10, we measure, for example, we consider the measurement of the diameter of one shaft 10 times after manufacturing. For 10 sample, for some shafts diameter come as a 5, for some shaft diameter come as a 8, for some shaft diameter come as a 5, 4, or some 3. Okay, so for total 10, the most frequently occurring observation is called as a mode. The most frequently occurring observation means what? The observation which occurs maximum time in the observation, that is called as a mode. Next, second important parameter in statistical analysis is a measurement of variation. Means first of all we have to go for the measurement of central tendency, and secondly we have to go for the measurement of the variation. Means once we measure the central tendency, in that we will get the arithmetic mean with the frequency. So how the variation can be measured? So there are two parameters in that. One is a variance. So variance is calculated or denoted by a sigma square and given as x1 minus mu square plus x2 minus mu square plus dash 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 plus xn minus mu square divided by n. So here what is meant by x1, x2, xn are the observations in that batch. Mu is the arithmetic mean that we are calculated previously here, mu with the frequency. Okay. Then x1, x2, x3 are nothing but the observations. So for number of observation, we will get the number of observations and arithmetic mean divided by n, total number of observations. From this formula, we will get the variance. Third one is the calculation of standard deviation. So standard deviation is defined as the square root of variance. If you take the square root of variance, it will be called as a standard deviation. So it is denoted by sigma and given as the square root of variance. So for this variance, if we take the square root of that variance, we will get the standard deviation. That is nothing but x1 minus mu square plus x2 minus mu square plus dash 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 plus xn minus mu square divided by n. So this is also nothing but a sum of xi minus mu square divided by n. So this formula will give us standard deviation. Square root of a variance is nothing but a standard deviation. So this is considered without frequency. Now if the observation x1, x2, xn repeat with the frequency, then we have to multiply that bracket term by frequency values for that particular observation divided by sum of observations or total number of observations, that is nothing but a frequency. So if you consider the observations with the frequency, then standard deviation will be the sum of fi into xi minus mu bracket square divided by n. So here sum of fi is nothing but sum of all these parameters. Okay. Fi xi means if there are 10, then x1 to x10 minus mu square. So divided by n, total number of observation. This formula gives you the standard deviation. Next one is a normal distribution curve. Next parameter is the normal distribution curve. If the curve drawn with respect to the random variable versus frequency, this curve is called as a normal distribution curve. So on x-axis, you can observe random variable x, and on y-axis, it is a frequency. Means the curve random variable versus frequency is called as a normal distribution curve. So for many physical measurement, follow the normal, or it is also called as a Gaussian distribution curve, which is symmetrical about arithmetic mean mu. So this curve is a symmetrical about arithmetic mean mu and extend from x is equal to minus infinity to x is equal to plus infinity. So from this here on x-axis, it will be the positive variable x, and on this side it will be the negative variable, that is minus x. Means what? This curve can extend up to positive infinity and this curve can be extend up to negative infinity. So such type of curve, if it is drawn random variable versus frequency f of x, x versus f of x, such curve is called as a normal distribution curve, and the symmetrical value will be arithmetic mean here. So from arithmetic mean to positive side and negative side, it will be 2 standard deviation, 2 times standard deviation. Next will be 4 times standard deviation. Next will be the 6 times standard deviation. Means this will give the population with the band. That is nothing but a accuracy 99.73, 95.45 and 68.27. Then this is the standard variable z and area under that graph. Means for z value from positive 0 and negative 0 to infinity, that values of z are provided. Means, for example, if Z value is comes, this will see in actual problems. So how that Z value is going to calculate it means conversion of standard normal distribution curve into standard distribution curve. At that time, the standard variable Z will be occurs. So here this curve is a normal distribution curve, but whenever we draw the standard normal distribution curve, at that time this mu will be replaced by another parameter, and x, positive x and negative x, will be positive z and negative z, and frequency f of x can be is replaced by f of z. So that curve is called as a standard normal distribution curve. At that time, we have to consider the values of z. The next point is the population combinations. So concept, what is meant by population combination? Many design application requires combination of two or more population to achieve the resultant population. Okay. For example, consider a case of dimensioning of mating part. The shaft and mating bearing diameter have their own dispersion. One may require a range of bearing which is assignable, or which he will assemble on the shaft with specified clearance range. Means, for example, if you consider the one shaft, and if you want to mount that shaft on a bearing, we must know the bearing size. Okay, so how that the diameter of the bearing and diameter of the shafts are now two different variables. Okay, means what? Do different population. The size of the shaft is one population size, and second size of the bearing is diameter of the bearing is also second population. We have to combine that to fit the shaft into the bearing. So at that time, we have to consider the population combinations. So what are the resultant populations are? Then resultant mean mu r and resultant standard deviation sigma r. Means if we have a two population x and y, then what will be the resultant population, what will be the resultant mean, and what will be the resultant standard deviation. So first one is the addition population. If you want to make an addition of two population, then x plus y will be the resultant population, r is equal to x plus y. Then resultant mean of that population will be mu x plus mu y, and standard deviation of that population is nothing but square root of a standard deviation of x population square plus standard deviation of y population square. Means if you want to combine two populations x and y, or two variables, or two observation x and y are these nothing but variables. Second one, subtraction of population. X and Y are the two populations. And if you want to subtract it, that resultant population will be represented by R is equal to X minus Y. Then resultant mean will be mu X minus mu Y. But the resultant standard deviation will be same as that of a addition population. Next one is the product of two population. The resultant will be X dot Y. The resultant mean will be mu X dot mu Y, and the resultant standard deviation will be cx square plus cy square into resultant mean mu r. Then division of two population, x upon y, mu x upon mu y will be the resultant mean, and square root of cx square plus cy square into mu r will be the considered as a standard deviation. Next, reciprocal of one population will be represented as a resultant population will be 1 upon x, r will be equal to 1 upon x, resultant mean will be 1 upon mu x, and resultant standard deviation will be cx into mu r. Then square of population will be represented by r is equal to x square, resultant mean will be represented as a mu x square, and resultant standard deviation will be represented as 2 times cx into mu r. Then cube of the population will be represented as r is equal to x cube, mean will be mu x cube, and resultant standard deviation will be 3 times cx dot mu r. Okay. Next, numerical constant k into x. If we multiply the numerical constant with the population, then resultant population will be k dot x. The resultant will be k dot mu x and the standard deviation will be k dot sigma x cap. Then sum of numerical constant will be represented as the resultant population r is equal to k plus x. Resultant will be mu r will be equal to k plus mu x, and standard deviation, resultant standard deviation will be represented as k plus sigma cap x. Next, design and natural tolerances system. So this will be, first graph is considered for the natural tolerance greater than the design tolerance. Second, natural tolerance less than the design tolerance. And third one is a natural tolerance equal to the design tolerance. So here you can observe that if the design tolerance is less than natural tolerance, means natural tolerance is greater than the design tolerance. So there will be rejection of the components. You can observe here rejection means natural tolerance is greater value and actual design tolerance is less value. At that time, you can get the rejection of the parts or components. Second, if natural tolerance is less than design tolerance, then your design will be safe. There will be less chances of the rejection. Then third one is a natural tolerance equal to the design tolerance. Also, there will be 6 sigma, means it will be less rejection of the components are observed there. Next is an example for it is observed. So we will see one example. It is observed from sample of 100 bolts produced on an automatic machine that their diameters are normally distributed with the mean of 10.5 mm and standard deviation of 0.02 mm. If the rejections are limited to only 5%, what will be the design tolerances? Assume the process is centered and use following table. So this is the table value for the Z. That I was told you why Z chart is required. So conversion of normal random variable into standard variable x into Z, this will require. So what is given in the problem statement? Mean is given as a 10.5 mm, standard deviation is given as a 0.02 mm, percentage of rejection is given as a 5%. That is automatically percentage of acceptance will be 95%. Percentage of rejection is 5%. Percentage of acceptance will be 95%. So you can observe, we can draw the graph for this is standard normal distribution curve, Z versus f of Z. So area under the standard normal distribution curve is calculated. A is equal to 0.95 by 2 is equal to 0.475. So putting the value from table, A is equal to 0.475, Z is equal to 1.96, Zx1 is equal to minus 1.96, and Zx2 is equal to 1.95. So from this formula, we will get the value of Z1 and Z2, x minus mu upon 100. Therefore, x1 will be equal to, so Z we know, sigma we know, mu we know. So we calculated the x1 value from Z1. So that will become as a 10.4608 mm, and for x2 it will become as a 10.5392. So these are nothing but the tolerances for this problem. If mean is given, standard deviation is given, percentage of acceptance and rejection is given, we can calculate the area from the table, and we can calculate the Z value from the standard values from the table. This area 0.475, Z will be minus 19.5, and for plus will be 1.96. Z will be positive 1.96. Next, example number 2, how the tolerances are going to calculate it, that we will see. So an assembly of three components as shown in the figure, find percentage of assemblies where interference is likely to occur. So these are the three components are given: component A, component B, and component C. So we have to find out how much percentage of interference is likely to occur. Okay. Assume normal distribution with natural tolerance equal to the design tolerance. So here part A, part B, and part C. So part A and B is called as a part X. So part A, we consider a combination of part A and B is considered as a X. So we consider it as a X. So upper limit is a 50.10 and lower limit is a 49.90. So here limit is given 50 plus minus 0.10. So from that we calculate the upper limit and lower limit. Upper limit and lower limit 50.10 and 49.90 for part A. For this part A only. For this part only 50 plus minus. 50 plus 0.10 is a 50.10 and 50 minus 0.10 is nothing but a 49.90. Then we calculate the mean. Mean of these two. Summation divided by 2. So that will be called as a mean. 50.10 plus 49.90 divided by 2. So we will get the 50 mm as a mean, arithmetic mean for the part A. The standard deviation of the part A will be the x minus mu divided by 3. Okay, so from that we will get the standard deviation for part A as a 0.033. Similarly for part B, we calculated mu as a 70. Same formula we have to use. For that, tolerances are given as a 70 plus minus 0.15, means 70 plus 70.15 and 69 point something it will come. So using that formula, we can calculate the mean of B. So this will be mu B 70 mm and sigma B will be 0.05. Then for part A, now we have to combine this part A and part B as a X. Part A plus part B means we are combining it, intersection. So that will be the part X, part A plus B. So arithmetic mean will be the mu A plus mu B, sum of population. So mu X is equal to mu A plus mu B. So that will become as a 120. Then resultant of standard deviation, that will be sigma x is equal to sigma a square plus sigma b square. So sigma a will be here and sigma b will be here, 0.033 square plus 0.05 square. So we will get the sigma x means standard deviation for the part x combinedly as a 0.06009 mm. Then for part C again same, we calculate the mu in same way. So here tolerances are given 120 plus 0.25 and 120 minus 00. So we'll get here mu as a 120.125 and sigma same way 0.042. Therefore, interference we have to calculate. Interference means what? Mu 1 is equal to mu x minus mu c. Mu x minus mu c. Mu c we have calculated as a 120.125 and mu x we calculated as a 0.06009. So putting that value, mu x is nothing but not a 0 point, mu x is nothing but 120. So here arithmetic mean for x is a 120 and arithmetic mean for part C is a 120.125. So we will get the minus 0.125 mm as a interference. So that will be the negative, indicates the clearance condition. Okay, then sigma 1 we have calculated as a sigma x square plus sigma c square. So sigma x will be 0.06009 and sigma c will be 0.042. So summation square root of sum of the both the standard deviation, we will use the standard deviation for the interference, that will becomes as a 0.07312 mm. So this will be the interference. Next is the analysis. So interference would occurs when I is equal to 0 or more. For I is equal to 0, Z0 will be I minus mu1 upon sigma 1. So 0 minus this term mu1 divided by sigma 1, we will get the Z0 as a 1.71 first value. Then for Z0 plus 1.75, I will be 0. So from Z0 to plus 75, that value is taken from the table. So a percentage of area indicating the interference is, so this will be the 50% minus this interference zone, we minus it, that will be the minus 0.4564. So this will be the what? Interference. So whenever we are minus it from the half of the area, we will get the percentage of area indicating interference, means this area we are getting as a 4.36%. So this is the answer of percentage of area indicating the interference, means overall is 1 from Z1 to Z positive to Z negative is what? 1. Total area under the standard normal distribution curve will be the 1. Therefore, half will be the 0.5 minus this area for Z is equal to plus 175. For Z0, the area will be 0.4564. So, taking subtraction of these two, we will get the 0.0436 as a percent area indicating interference for that particular component. So, it will become as a into 100, it will become as a 4.36. Thank you for watching.